All right, here's an f of x. We're supposed to find its intervals of concavity and its points of inflection, if any. So that means we need a second derivative. The first derivative is, it's a quotient, so quotient rule. Bottom times derivative of the top minus top times derivative of the bottom all over the bottom squared. I'm not sure why I bracketed that. It didn't need to be. Okay, so we get 2x squared minus x squared, and then we get minus negative 1. So there's our numerator. And if we now do a second derivative, quotient again, we get bottom d top minus top d bottom all over bottom squared. Now we're up to x to the fourth. Expand this, and it's 2x cubed minus 2x cubed and minus 2x. Yeah, that's right. Okay, so the 2x cubes just cancel out, which is fine with me. And so our numerator just ends up as minus 2x over x to the fourth, which cleans up to minus 2 over x cubed. That's our second derivative. Now, when we're looking for interesting points on the second derivative, we look for two things. Where is this 0 and where is it undefined? If it's 0, we get minus 2 over x cubed equals 0. We multiply both sides by x cubed and we get negative 2 equals 0, which is the math saying, no, this is impossible. Walk away. So there are no places where this equals 0, but it is undefined if x equals 0, because then we get a division by 0 and we can't evaluate that. So the one interesting point on this second derivative is when x equals 0, we'll see how the derivative behaves around there. If x is negative, let's say it's negative 1, we get negative 2 over negative 1 is a positive number. If x is exactly 0, then we get undefined. And if x is positive, we get negative 2 over something positive. So this function is concave up below 0 and concave down after 0. Now, it's possible for an undefined point like this to be a point of inflection if the original function is defined there. You remember we can get curves that have an s-bend, maybe something like this, where at this point the second derivative is undefined, but it still counts as a point of inflection. So that's possible if the original function is defined at 0, but it isn't. At x equals 0, this function is negative 1 over 0, which is undefined, so this 0 does not count as a point of inflection. We have intervals of concavity, which are up below 0, down above 0, but we do not have any points of inflection for this thing.